This video is dedicated to understanding scientific notation and how to use it in basic operations. Now here's the deal. Scientific notation is used in order to take extremely large numbers or extremely small numbers, numbers that have tons and tons of zeros. And how can we understand these numbers without literally counting zeros? Well, the idea is we use exponents. And we use 10 to a certain power because by multiplying or dividing by 10, all you're really doing is moving the decimal place. So that way we can take like 1 trillion, divide it by a billion, multiply it by another quadrillion, whatever you want to do. And instead of counting zeros, you're simply just adding or subtracting exponents. So the first part of this lesson is first, how do we convert standard form numbers? Okay, standard forms just like we're used to, as we can see in these examples right here. These are all standard form right here. And how do we convert them to scientific notation? Now the deal for scientific notation is the leading number is some number between 1 and 10. Okay, so it has to be less than 10, all the way up to like 9.9 for instance. And it has to be bigger than 1. And the decimal place is always in the same position. It's the dot right behind the first digit. And then in order to understand how big or small the number is, we look at the exponent. Okay, so we can see right here, how do we express 1 million? Well, if we put the decimal behind the 1, how many times do we have to move the decimal place? Okay, 6 times, and that's why it's 10 to the 6th power. Here, put the decimal right behind the first digit, okay, and we move it 5 times, and that's where the 5 comes from. Here, notice now again, we don't put it behind the zeros, the first digit that's not a 0, so back here, and we move it 1, 2, 3, 4, okay, 4. Now the question is, how do we know if it's positive or negative? What I like to do is big numbers have a positive exponent, and in small numbers have a negative exponent. So that way you don't have to worry about memorizing, do I go right, do I go left, because it's going to change in every scenario. So think, is it a big number? I'm going to have a positive exponent because I'm multiplying by 10. If I'm multiplying by a negative exponent, that really means division, which means the number gets smaller. Okay. All right, so let's take a look here at some more examples. So how do we write 2 million in standard form? Well, that's simply 2 and then, a bunch of zeros like that. And I could put the commas in, but I'm going to leave them out for right now so we don't get confused on that. And then 5 thousandths. So that's 0.005. So again, we have tenths, hundreds, thousandths. Okay. So scientific notation, I'm going to take the first non-zero digit, put a dot right after it. Say, okay, if I put the dot right there, I'll change color so we can see it. How many times did I move? 1, 2, 3, 4, 5, 6. So times 10 to the 6th power. Okay. And since it's a big number, then it's a positive 6. Okay. And again, you could put 2.0, but you don't have to put a 0 here. Standard scientific notation also is not a rounding mechanism. You write the actual number. It's just a different way of showing it in exponential notation. So 500. So I'm going to do 5 points. So if they put the point behind the first digit, we move it 1, 2, 3 times. So times 10 to the 3rd. But since it originally was a small number, it's -3. So that's how I like to look at those. All right, so let's do some practice here. So I'm just going to show you, okay, over here we have standard form, and then to the right we have scientific notation, okay? So how do we write this in scientific notation? I'm going to put the dot right behind the 3, so it's simply 3.6. And you write down all the digits that are non-zeros after it. So we'll see that more down here. Times 10 to what power? So how many times did I move? 1, 2, 3, 4, 5, 6, 7. So to the 7th power. Okay, but obviously this is a lot easier, smaller, more condensed to write than having to count zeros. Let's go backwards. 6.72. So I'm going to write 672, and we're going to move it 7 times. So if I started with the dot behind the 6, 1, 2, 3, 4, 5, 6, 7. So it's not 7 zeros. You move the decimal place 7 times. So notice as a standard number, that's 67 million. Okay. Let's go back this way. Now notice I put the dot behind a 9, so it's 9 point, and I put down 275. And once I hit the zeros, then I don't have to write them down. But notice I have to write down all 3 decimal places here because we're not rounding. We're just writing number in a different form. And in 10 times what? It's a big number, so it's going to be a positive exponent. And we move it 1, 2, 3, 4, 5, 6, 7 times. So hopefully you can see me moving my pen, and I'm just literally counting how many times I'm moving the decimal. Let's go ahead and just do one more. I'm going to do this one down here. So I'm going to write 1.78, and then I hit 0, so I'm done, times 10 to the positive, because it's a big number. And I'm going to move it 1, 2, 3, 4, 5, 6, 7, 8, 9. So positive 9. You don't have to put the plus sign there, but you may want to get used to it. And um, and then just let's just talk about this one. So this one's going to be a big number because it's a positive exponent. So it's going to be 2794. So let's move the decimal. 1, 2, 3, 4, 5, 6, 7, 8, 9. So there we can see, 2 billion and change. Okay, so there are some good examples of how to write scientific notation both ways. All right, so let's just get ahead and let's try some examples. Write each number in scientific notation. So let's go ahead and do this one here. I'll just fly through them. 2.79. How many times did I move? 1, 2, 3, 4, 5. And it's a big number, so it's positive. This one here, I'm going to put 7.3 times, and I move it 1, 2, 3, 4. 4 times, and it's a small number. And I know it's small because it's a decimal. The numbers are behind the decimal place. So it's a negative. Okay. Now notice this one here, number 4. A lot of people say, well, that's already in scientific notation. No, it's not, because 93 is a number not between 1 and 10. So I'm going to change 93 to scientific notation, which is 9.3 times 10 to the first power. So notice I started here, I moved the decimal one time, and it's a big number, meaning bigger than 1. And so I know it's a positive exponent. So then I'm going to go ahead and copy down this part of the problem. Okay. And then we can say, okay, what do we do with exponents when the bases are the same? Well, this is really 9.3 times 10, and then we just add exponents. 1 plus -5 is -4. And it really is the best way to go about that problem, is convert the front to scientific notation and then add the back. The whole point of scientific notation, again, is so we can do addition, subtraction, or more or less multiplication, division very easily by working with numbers between 1 and 10, very simply. Use your calculator if needed, and counting exponents. Okay. So let's go ahead and let's try this one again too. So this is going to be 5.2 times 10 to the first power, and then the back half is times 10 to the fifth power. So if I multiply them together, it's 5.2 times 10, and then 1 plus 5 is 6. Okay, so that's a great way to do that problem. All right, so let's take a look at perhaps some examples down here. Okay. So one example here is we're just going to take 3.7 and we're going to move it 5 times, but to the left. Okay, so 1, 2, 3, 4, 5, and I'm going to put my decimal. So that's how we're going to write it in standard form. Okay, I want to take a look at a couple examples like 13 and 14. So this is the reason why we use scientific notation, is I don't want to multiply really big numbers because you're just counting zeros and so forth. So how do we do a problem like this? Well, just like we did before, we want to multiply the first two numbers together. So I'm going to use my calculator over here, and I'm going to multiply, let's get that out of the way, turn it on. So 1.17 times 3, and let's use your calculator for this, and we get 3.51. Okay, so let's go back and write that in. 3.51. And again, what do I do now with the bases that are the same? Well, that's 10 to the first power and 10 to the fourth, and these are simply being multiplied. So that's really just 10 to the fifth power. And notice we're able to combine those two, larger numbers using scientific notation. So, if I was to write in standard form, that'd be 3, 5, 1, and then add 3 more zeros because we moved it 5 times, and 351,000. Okay. Some people would look at this and say, can I rearrange it so I can see it better and write it like this? Yes, you can, because it's all being multiplied. You can rearrange it for sure. So I kind of do that as a problem and that as a problem. All right, so let's go ahead and try this one here. So again, I'm going to use my calculator off to the side, and I'm going to type in 7.87 um, times 6. Okay, and notice here I get 4722. So let's write that down. And then let's do our exponent piece. So 10 to the fourth plus a negative 2, so that's 10 squared. Now notice, just like before, this number is bigger than 10. So we have to change just this part. I'm going to do it in a different color. And it's going to be 4.722 times 10 to the first power. Now I know it's positive 1 because they moved the decimal place one time, and it's a bigger number. Again, bigger than the 1 to 10 range. 47 is obviously bigger than 10. So that, and then I'm just going to copy down the 10 to the second power. And then my final answer is 4.722 times 10 to the third. And notice how I just added the exponents there. So that's how we want to write it. Again, you know you're done when your first number is a decimal form between 1 and 10. Okay. So like I said, 15 and 16 might be good examples for you to try. I'm going to go through 2 more examples to show you, just with division. So let's go ahead and just do this one right here, 17 and maybe 19. Let's see how 17 looks. So again, I'll use my calculator, and again, I'm just going to do this portion of it first, the numbers with numbers. So we have 7.94 divided by 5, and we get 1.58. 1.588. Notice I write down all the digits. I'm not rounding. And in here, since we're doing a division problem, this is really 10 to the 6, and then we move the negative 4 up top. It becomes positive 4, so it's 10 to the 10th power. So that is our final answer. And notice I check it because this number is in between 1 and 10. Now notice in this example here, we're going to get a number that's a decimal that has to be converted. So let's do this one here. This will be our last example. 3.58 divided by 7.34. And we have 0.48. Now in this case, notice the extreme number of decimals, digits, so I'm just going to round. Let's just go 3 decimal places. So notice I changed the 7 to an 8 because I'm looking at the other 7 over here. And then times what? 10 to what power? So again, I'm going to move that negative 6 up and make it a positive 6. And then I'm going to add those exponents, so it's 10 to the 8th power. Now again, I'm not done because notice this decimal is not between 1 and 10. So I got to change it to 4.88 times 10. And I moved it one time, but since this is a small number, less than 1, a decimal, it's negative 1. And then I copy down 10 to the 8th, just like we did from before. And then my last step is simply add those together. So what's 10 to the negative 1 plus 8 to the 7th power? And right there we can see what's going on. Okay, so that kind of concludes our work with scientific notation. Again, the major objectives are, can you change between standard and scientific forms? And then can we use basic multiplication and division using scientific notation?